So our next case study is going to be called Identifying Pitfalls, Costly Drilling Mistakes. This is an overview in the Cardium, Canadian oil play. It's a 4-well study. The first well in the study is an old vertical well drilled in 2008, and then 3 horizontal wells get spud between 2010 and 11. RTA was used to understand the impact of well interference from the producing offsets prior to drilling the well in 2011. The study is going to demonstrate the value of using RTA to avoid costly mistakes. So here's the case study. There's your vertical well. There's your first horizontal well. There's your second in 2010. And the operator drilled a well right smack dab in the middle. At the time of the analysis, for the data that we had, using a very rough, crude approximation of region or radius of investigation, we can see that there's an obvious drainage area overlap with these wells. This can be indicated diagnostically in the analysis plots of rate transient analysis. Here we can see in the flowing material balance in the bottom left-hand corner that there is an interference effect indicated in the data at exactly the same time when the new well came on stream. And that's indicated by the data coming off that straight line and hooking down. Analogously, on the type curve analysis to the right-hand side, we can see productivity loss exhibited in the data as we come off that type curve and we're no longer on unit slope. So in this case, the RTA could identify this quite quickly. Numerical modeling also reveals the same thing. This shows, using a far more rigorous approach that can account for multi-phase flow effects, because of course the previous work was done analytically using single-phase liquid compressibility assumptions. This accounts far more rigorously for the data, but we can see the story is the same. That at the time that the new well was spud, we lose our history match, our productivity starts to suffer. And at that point, we can look at what the average, of an approximation of what the average reservoir pressure should be at that point for a quarter section. And that is initial reservoir pressure that's roughly a third of what the field was to start. So going from, say, 3,000 pounds to 2,000 pounds, something like that. Now looking at that horizontal well, the latest well that was drilled, that was causing this problem in the vertical well and in the other horizontal wells as well, that it had 3.5 years of production history when we looked at it, because it was a 2011 well, and its EUR was only 21,000 barrels, despite the fact it was a 10-stage completion in good rock. The RTA interpreted pressure depletion from the offset well production is something that could have potentially prevented this drill location. To show some more features of RTA, if we just looked at the single vertical well type curve analysis to the left, I showed previously what that interference diagnostic would look like. Doing multi-well analysis, performing that and accounting for production for both wells, trying to compete for the same hydrocarbon in place, we can see that the methods allow us to correct for this behavior, which validates the fact that they are stealing the same production. And so this is more of a post-mortem tool, but in that case, but this was probably an avoidable mistake.